Jai Hind students, welcome to my YouTube channel. Students, the pessimist sees difficulty in every opportunity and the optimist sees the opportunity in every difficulty. So, you need to be an optimist where you need to have that positive approach towards life. That positive note, students, let's begin today's session. In today's session, we'll be discussing the NCERT textual questions. That is, we'll be discussing the numericals which are given in NCERT textbook, right? So let's begin with the first question then. First question is, a force of 7 Newton acts on an object. The displacement is 8 meter in the direction of the force. What is the work done by the force? So the situation is like this. This is an object which is given and it is under the influence of force of 7 Newton, right? Suppose the force is acting along this direction. This force is given to be 7 Newton and under the influence of this force, the body gets displaced by a distance of 8 meter in the direction of the force applied. So the body moves along this direction and it gets displaced along the same direction. S is suppose the displacement. So it gets displaced by a distance of 8 meter along the direction of the force applied. Now students, we are very much aware that under the influence of force, when the body gets displaced along the direction of the force applied, then work done is simply given by the product of force and displacement. This formula is valid only when the displacement of the body is along the direction of the force applied, right? So here simply we need to substitute the value and solve it. F is given to be 7 Newton. S, the displacement is given to be 8. So it will be equal to 56. And it is given in SI 7 Newton. Displacement is given in SI 8 meter. So work done in SI, its SI unit is Joule. So work done by the force in displacing the body by 8 meter along the direction of the force applied is 56 Joule, right? So it's a very, very simple question based on this direct formula. Now let's proceed to the second question. Second question is, a pair of bullocks exert a force of 150 Newton on a plow. The field being plowed is 15 meter long. How much work is done in plowing the length of the field? Total length of the field is given to be 15 meter, right? And bullocks exert a force on 140 Newton on a plow. So this force must be exerted along horizontally and the field being plowed, obviously, it is along the same direction as that of the applied force, right? So in this case also, this is suppose pair of bullocks which exert a force of 140 Newton, right? This is the force, 140 Newton. Obviously, it will get displaced along the same direction horizontally. So this displacement or the length of the field which is being plowed is given to be 15 meter. So obviously work done in plowing the length of the field would again be given by simply the product of these two. Why? It is because the displacement obviously is taking place along the direction of the force applied, right? So over here work done in plowing would be naturally given by force into displacement along the direction of the force applied. So that will give us 140 multiplied by 15, right? So it is equal to 2100 Joule. So this much work is done in plowing the length of the entire field, which is 15 meter long, right? So it's pretty simple. Now let's concentrate on the third question now. Third question is, The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What is the mass of the body? So let's try to attempt the first question first. Kinetic energy, students, you are aware, it is the energy possessed by a body by virtue of its motion, right? And kinetic energy is given by half mv square. M is the mass of the body, v is the velocity. So kinetic energy is given to be 25 joule and velocity is given to be 5 meter per second. That is kinetic energy, it's given to be 25 joule. Half into mass into velocity, it's given to be 5. So 25 get cancelled. So mass of the body would be equal to 2 kg. So that's the answer of the first part, right? So mass of the body, it is 2 kg. Now let us find out the answer of the rest of the parts. Okay. Now in the second part, what we are supposed to do is, what will be the kinetic energy when its velocity is doubled? Now students, look. This is the first part, right? And second part. Kinetic energy, as I stated, it is equal to half mv square. That is, half is constant, mass of a given body is constant. Therefore, kinetic energy of a body is directly proportional to square of its velocity. Clear? So, what will be the kinetic energy when its velocity is doubled? So, students, if v dash is equal to 2v, then if the velocity is doubled, then what happens? It will become 4 times. The new kinetic energy, would be equal to 4 times the previous or initial kinetic energy. Look students, when the velocity is made twice, kinetic energy will become 4 times. When the velocity is made thrice, kinetic energy will become 9 times. When the velocity is made 4 times, the kinetic energy will become 16 times, right? So in case the velocity is doubled, then kinetic energy will become 4 times. That is, new kinetic energy in this case, when the velocity is doubled, would be 4 multiplied by the original kinetic energy, which is 25 joule. So that would be equal to 100 joule. Right? And in third case, students, what would be the kinetic energy when its velocity is increased 3 times? When it is increased 3 times, when the velocity is made 3 times, kinetic energy will become 9 times. So now, new kinetic energy would be 9 times the original kinetic energy. So it would be equal to 9 multiplied by original kinetic energy is given to be 25 joule. So it will be equal to 225 joule. Now let's proceed to question number 4. Question number 4 states that a lamp consumes 1000 joule of electrical energy in 10 seconds. What is its power? Power, students, we have discussed, it's the rate of doing work or rate of consumption of electrical energy. So power of an electric device is the rate at which it consumes electrical energy. Rate means amount of energy which is dissipated or consumed divided by the time during which that energy is consumed, right? That is, power of a device is given by the electrical energy consumed or work done. Electrical energy consumed. In case of an electric device, and in case of any object, it would be work done per unit time. In case of an electric device, power is the rate at which electrical energy is consumed. So electrical energy consumed divided by time. So that's electric power. So the energy consumed by the lamp is given to be 1000 joule. Now in what time this energy is consumed? In 10 seconds. So joule per second is watt, 1000 by 10 is 100. So it will be simply 100 watt. So the power of the given lamp must be 100 watt, right? Now let's proceed to this question, question number 5. Calculate the work done by the force when the force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. So mass of the body is given to be 20 kg. And the body changes its velocity from 5 meter per second to 2 meter per second. So initial velocity is 5 meter per second. And final velocity is 2 meter per second. Right? We are supposed to find out the work done. Look students, as per the work energy theorem we have discussed, whatever work is being done in changing the velocity or the motion of a body gets stored in the body in the form of its change in the kinetic energy. So, as per work energy theorem, work done is equal to change in the kinetic energy. Change is the final kinetic energy minus the initial kinetic energy. KEF, it stands for final kinetic energy. KEI, it stands for initial kinetic energy. Final kinetic energy is half mv square. V is the final velocity. And initial kinetic energy is half mu square. U is the initial kinetic energy. Right? So it is half m v square minus u square. Right? So let's substitute the value over here. Half mass of the body, it's given to be 20. Right? Final velocity, it's given to be 2. So it will be 2 square minus initial velocity is 5. It will be 5 square. So what we get is 10, 20 by 2 is 10 multiplied by 4 minus 25. So it is equal to 10 multiplied by minus 21. Isn't it? So it is equal to minus 210 joule. Clear students? Now this negative sign suggests that the force must be acting in a direction opposite to that of the direction of motion of the body. That is why work done is negative over here. Now look, the velocity of the body is changing from 5 meter per second to 2 meter per second. That is, the body is retarding. So this must be the case. Suppose this is the body and this is the direction of motion of the body. This is the displacement of the body. So since the velocity of the body is decreasing, therefore the force must be acting in a direction opposite to that of the displacement of the body. And we are aware, students, whenever the force acts in a direction opposite to which the body moves, then it is a retarding force. And work done by a retarding force is always negative. Right? So the answer is minus 210 joule. Okay, let's proceed with the question number 6 then. An object of mass 40 kg is raised to a height of 5 meter above the ground. What is its potential energy? Now, potential energy, we are aware, it's the energy possessed by a body by virtue of its configuration, by virtue of its position, by virtue of its height, isn't it? So, potential energy of a body of mass m when it is raised through height h is mgh. So it's a simple formula to be used. So for the first part, what we do is potential energy of a body is simply given by mgh. Mass of the body is given to be 40 kg. G is suppose 10 meter per second square. G is the acceleration due to gravity. In the question, suppose it's given to take G as 10 meter per second square. So G is 10 and the height through which the body is raised is 5. So it will be equal to 400 multiplied by 5, and that is equal to 2000 joule. So this is the potential energy possessed by the body when it is raised to height of 5 meter, right? Now it is to be noted that this is the maximum height where the kinetic energy is 0. Kinetic energy at this point would be obviously 0. Initially it will be at rest. So therefore, total energy we have done at any instant is given by sum of potential energy and kinetic energy. So it will be equal to 2000 plus 0. So that will be equal to 2000 joule. Clear, students? Now second part. If the object is allowed to fall, find its kinetic energy when it is halfway down. This is the object which is taken at a height of 5 meter. Now it is made to fall freely from here. At the highest point, initial velocity is 0. Right? So all the energy at point A, at the highest point, would be in the form of its potential energy. Kinetic energy at point A is 0. Now as it falls, at the midway, we are supposed to find its kinetic energy, right? Here the kinetic energy is to be found. Now as the body falls, it will lose in height and will gain in velocity. So whatever is the loss of potential energy, it would be equal to the gain in kinetic energy. Or students, you can apply the law of conservation of energy, obviously. Total energy at point A would be equal to total energy at point B, isn't it? Point B is midway, that is, it is at a height of 2.5 meter. So what we can do is, applying law of conservation of energy, total energy at point A must be equal to total energy possessed by the body at point B. That is, the energy of this body throughout its motion must remain conserved, and the total mechanical energy is given by the sum of kinetic energy and potential energy. So we are very much aware energy can neither be created nor it can be destroyed. That is, total energy remains constant, but it can be transformed from one form into another form. So when the body falls, its potential energy gets converted into kinetic energy, isn't it? So loss in potential energy would be equal to gain in kinetic energy, but the total energy at any point during its motion must remain constant. So that is what I have written over here. Total energy at point A, it should be exactly equal to the total energy possessed by the body at point B. Therefore, total energy at point A, it is equal to 2000. This we have already calculated. Total energy at point B, it is at point B, the body possesses both potential energy by virtue of its height, and it will also possess kinetic energy by virtue of its motion, isn't it? So it will be potential energy at point B plus kinetic energy at point B. So therefore, 2000 is equal to potential energy at point B. At this point, it would be mass mgh. Mass is 40, g is taken to be 10, and h is 2.5. Plus kinetic energy at point B. So therefore, students, this will be 2000 is equal to, this will give you 10 gets cancelled, 25 400, so it will be 1000 plus kinetic energy at point B. So students, taking 1000 over here, what do we get? Kinetic energy at point B would be 1000 joule. So the kinetic energy of the ball at midway would be equal to 1000 joule. So this is the answer of the second part. So I hope students you have understood the concept, right? So we'll conclude this session. In the very next lecture, we'll discuss some other NCERT numericals. Till then, keep practicing such questions. And stay fit, stay healthy, and always keep smiling. Thank you.